Yes, dear students, now very important topic collision. In this chapter, collision is a very important topic. Uh, if you are studying my videos regularly, then start doing problems of test book, especially first NCRT book and then other. I have uploaded many videos regarding numericals of work power energy. Now I start here. Collision. When two or more bodies coming towards each other strike with each other, then we say collision has taken place. Generally, the two bodies may be moving in same direction, having different velocity. Suppose it is u1 greater than u2. So the length of arrow represents magnitude. So naturally, this mass m1 coming close to this and will strike. And in this strike, when they strike, we say collision has taken place. The collision here in physics, we take two types of collision. Two types of collision are there. Number one, elastic collision. Elastic collision. This topic very important for further study also. And number two, inelastic collision. Inelastic collision. So here we will define which collision is called elastic. So very simple definition, elastic collision. The collision in which momentum and kinetic energy, not energy, only kinetic energy. Kinetic energy remains conserved. Then the collision in which momentum and kinetic remain conserved is called elastic collision. It's called elastic collision. Which one? In which momentum and energy both remains conserved. It's called elastic. In fact, practically no collision is perfectly elastic. Why? Because some kinetic energy is lost in the form of heat, light and sound. You might have heard when some collision occurs, you get sound. But when kinetic loss is negligible small, in some cases, kinetic loss is negligible small. And so where you can write here, if kinetic energy lost is negligibly small. Negligibly small. Then we can treat the collision as elastic collision. देखो ये बड़ा it is very difficult to understand for children कि when it is said to be negligible, and I keep on telling again and again what is negligible. If total energy kinetic 10 to the power 5 joule है and loss is only 0.01 या 0.1 joule है, so this is negligible. You can't have 10 to the power 5 plus 0.1. So that way this is called negligibly small. So the collision in which kinetic energy lost is negligibly small can be taken as elastic collision. The atomic size collision, when atomic size particles collide, although electrons produce large amount of heat, when we pass electric current, conductor get heated. You know why the heat is produced? In class 12 you will learn when current pass, there is a big number of electrons inside the conductor, and that big number of electrons collide very frequently and heat produce that, and that raises the temperature of wire. तो ऐसा नहीं कह सकते कि भाई एटॉमिक साइज पार्ट, बट in some case like nuclear reactor, है ना, the collision between two protons or proton neutron can be taken elastic collision. So when kinetic energy loss is negligibly small, then the collision is said to be perfectly elastic. We can treat that as elastic collision. Now in elastic collision, it is only quantitatively told, qualitatively told by what is collision. We will come quantitatively also. Then inelastic collision. Dear learner, please keep on telling me if you don't get something, because here I am in hurry. I want to put maximum information in one video. That is my problem. So I under pressure may commit some mistake to save time and to upload a large information to you. Some mistakes are done by me. Some when I see myself, I find it, but you people don't tell. Some people have commented upon some quality, etc., and I am trying to improve it day by day. I think sound problem has finished. Now in elastic collision, the collision between two or more भी हो सकता है, more bodies in which momentum is conserved, but kinetic energy only, not energy, don't get confused. Kinetic energy is lost, but kinetic energy is lost is called inelastic collision. Inelastic collision. Actually, in class teaching, student remain with me. I keep on dictating on the, I don't write on board. Here I am writing on board because you people are not with me. You may, while observing the video, you may lose concentration. So I write here. In fact, every collision is inelastic. In fact, every collision is inelastic. In my whole teaching life, no student has asked me why momentum is always conserved. In any what type of collision is there, whether elastic or inelastic. So momentum remains conserved. Why? Nobody has asked me. I tell myself. You will are not here. Actually, when bodies collide, what is the law of momentum in fact? The law of momentum states that momentum of body or sum of momentum of body, system body remains constant in the absence of unbalanced external force. Momentum remains conserved in the absence of unbalanced force, or you can say if no external force acts on system bodies, then total momentum remains same. When bodies collide, they apply force on each other. When they collide, their momentum gets changed. But momentum before collision is equal to momentum after collision. Why? Because the force acting on them is due to each other, and this force is called internal force. Momentum remains conserved in every collision because the force acting on them is internal, not external. So when law of momentum याद रखिए, keep in mind what is law of momentum. Momentum, system, momentum body or system body remains conserved in the absence of unbalanced external force. So I told you, this. Now if after collision, if after collision bodies get embedded into each other, then the collision is called perfectly inelastic collision. Inelastic collision or plastic collision. Plastic collision. Which one? The inelastic collision in which bodies after collision get embedded or get coalesced into each other. They become one and move together. Then collisions have to be perfectly inelastic. For example, when a big vehicle moving collide with a small vehicle and that gets into it, they move together. That type of collision is called perfectly inelastic collision. Now in next video I will take here First I will take elastic collision in 2 dimensions and then head on elastic collision in 1 dimension, then perfectly inelastic collision in coming videos. Thank you. मिलते हैं.